Hello Year 12 and welcome to another lesson on coasts for the A-Level Edexcel Geography Spec. Today we're going to be looking at the difference between lithology and geological structure and how do these different factors affect the coast. Now I'm not going to go into a massive amount of detail. You should have already watched the video that I asked you to view, which went into great detail onto the impacts of both of these. But because it's such an important factor, I just want to give you the opportunity to check your understanding, but also to highlight some of the key mistakes that pupils have made in the past. So listen carefully. Now this is one area that you really need to follow the spec on, or the specification, because it is very particular and specific about what certain words mean here. One of the big mistakes is that people think, oh, they're talking about geology, and they will get geological structure and lithology mixed up. Now, although they are similar, for this specification, they are treated as very different, and students will often lose marks when they see a question about structure, they start to talk about lithology. And so this is where you need to refer back to the specification. Look at each of these different points. Look at A, B, C for 2B.2. What is it asking you about? What do you need to know? What links does it make? And so when you see these words in the exam, that's what you've got to make sure that you are relating to. It's part of the skill of the A-level course. It's not writing a lot, but it is being very specific and relating it back to the specification. So, okay, what is the difference between the two of them? What I want you to do is just think about and write down different definitions for each of those terms: geological, structure, and lithology. Pause the video now. Okay, so you should have had a go. Let's see what answers you could get. Well, geological structure is when we're looking about the concordant or discordant nature of the coastlines. Do the rocks lie perpendicular, or do they lie parallel and right angles, or at right angles? It can also relate to the strata in individual cliff faces. So we're looking at the different layers of how the different bedding planes are layered, the deformation caused by tectonic or rebound or earthquakes, but also the faulting in the rocks as well, again caused by the tectonic pressures. Lithology relates to the three major types of rock: igneous, metamorphic, and sedimentary. But it is also important to realise that you need to consider the role of unconsolidated rock. When you get things like clay or soil-based cliffs, these will erode very, very quickly. So even though they are classed as sedimentary, they are classed as unconsolidated because they don't act like rock. They will just act more like a soil. They're not bound together. They've not been compressed. Also, you need to understand how these features of rocks can be affected or affect the rates of erosion, weathering, and mass movement as well. So, a quick test on your knowledge here. We've got two different types of coastline. And what I want you to do is just write down what is the term for this type of coastline that we can see here, and what would we say about the coastline here? What are the key elements to it? So pause the video, have a go now. So what you should have got is this is a discordant coastline because the rock is lying in bands at right angles to the coast. So we can see we've got some harder rock here, and then in between, forming these baylets, we would have the softer rocks. Here we have the Dalmatian coast in Croatia, where we're seeing, instead of these headlands and bays and baylets, we're seeing these island chains parallel. Now, there are a whole range of different reasons for how these are formed, and we'll cover more of this in the course later on. But these are formed when the tectonic plates, the Eurasian and African plate, push together, causing massive folding of the rocks, leading to anticlines and synclines. So you would have had these very long hills in parallel shape. Then over millions of years, with changes in sea level, these valleys or the lower areas have flooded, so leaving these islands parallel to the coast. So would you say that these changes are these caused by the structure or the lithology? And you'd be right if you said structure. These formations would be related to the geological structure of the rocks. Now, what you can do, I've already answered that. You could write down in your folders, why are these coastlines so different? Off you go. So let's have a review then. So what we've got are these concordant coastlines. Now we can see we have the south coast of Dorset, and we can see the rocks are lying virtually parallel along it. And because of this, we're getting some of these unique shapes. So we have still got sort of areas that look possibly like headlands and bays, but they're formed because of differential erosion in the same type of rock. And we can also get things like coves and holes formed in these areas. And this is because although we've got something like the Portland beds and chalk can be harder, it can still be eroded, and over thousands of years this can lead to differential erosion, creating these unique shapes here. On the bottom right we have the Dalmatian coastline again, and then on the left here we have something called a half coastline. Now whereas the Dorset coastline is due to erosion, the Dalmatian coastline is formed by sea level rise, although you might think, well, that's the same. But actually this half coastline in northern Europe is formed by deposition. So you can have very similar coastlines, but they can have a number of different ways of being formed. And then we have the discordant coastline, where the rocks lie at right angles. And this is where we tend to find these traditional iconic headlands and bays. But it's very important to recognize that when we're talking about the geological structure, it depends what the rock is next to. For example, if you had chalk next to clay, then chalk would be a relatively hard rock type and would erode more slowly than the adjacent clays. However, if chalk was next to slate or granite, then that would be the softer rock, and so that could possibly form the bays. Then you get mixed in as well the idea of when the headland is formed, then that will start to diffract the wave energy and will lead to whole different changes within the bay as well. So again, it's this idea of equifinality. There's many different ways in which similar landforms can be created. But all of these here, we would be talking about geological structure and the impacts on the landscape. Although you might talk about the lithology of the different rock types. So the chalk of the bay in Swanage, the clays in the bay of Swanage compared to the chalk of the headland. Now remember earlier I mentioned the importance of checking the specification and looking at the words that it wants to go. And this is a classic example of mistakes that can be made. This is actually taken from one of the textbooks. And if you look here at what the textbook actually says. So it's also related to its geological structure, known as its lithology. Now that is going to be very confusing. Whilst technically it is correct, it is wrong in terms of this specification. So be very careful that when you are making notes, you do refer back to the specification, because as it notes here, lithology is about the physical characteristics of particular rocks. The geological structure is talking about the strata, the bedding planes, the joints, etc. So be careful when you're making your notes so you get that understanding of lithology and geological structure. So again, when you're looking at geological structure, not only do you get the concordant, discordant coastlines, but it also has an impact on individual cliffs. And you can see here within these diagrams that the impact and the direction and dip of the bedding planes can have a big impact on the shape of the cliff. So you can pause this and have a look. Now here is a mixture of geological structure, which is how the different rock types sit on top of each other, and it's also the direction of the bedding plane. But within the bedding plane, we have rocks with different lithology, different characteristics, which can lead again to these unique and differentiated cliff profiles. There is a heck of a lot to try and understand, and there is so many variables. Is that all you can do when you see an image is you can try and apply your understanding to make a logical explanation. It may not be the exact correct answer, but as long as you show you are applying your understanding to make a reasoned conclusion, then that is what A-level geography is all about. So you've got a couple of images here. Thinking back to what we've already done and drawing on your wider knowledge, you can pause the video and just write down what you think some of the key factors are that have impacted the shape of these cliffs. So have a go now. Okay, well, first of all, let's describe the lithology. And you can see that this would be an unconsolidated sedimentary rock. This is just clay and soil mixed together, very, very loose. You can see that there's not really any bedding planes or any layers in there, so the whole cliff is just falling prey to rotational slipping and slumping. As the base gets eroded, this all gets saturated by the rain and it collapses down. Whereas here, this is also unconsolidated, but there are more layers in there. And you can see the marine erosion at the base, but there is a slightly more consolidated layer above that, which is leading to this very different shape of it. So on the next slide, I'm just going to play this through and just have a look. We've seen some of these images before, but what do you think? Lithology, geological structure, both of them, how do they have an impact on these coastlines? And what other factors may influence them? And here's some more. Pause the video, study them, and press play when you're ready to go again. Now, one of the things, it's all very well studying in books and having an understanding of them, but it is important in geography that you do have relevant case studies. And I would seriously recommend that you get yourself onto Google Earth, or you get yourself onto some maps, aerial photography, and look at these different locations. Where are they? What's the geology of the area? What is the land like? What it would be like if you went down there? Yeah, can you drop your little man and have a look around there? This is how you're going to really start to understand it, when you start to see these images rather than just diagrams in a textbook. And so you don't need a massive amount of information, and you might want to work together on this. But it is worth investigating these different areas just so you understand some of the key geological lithology of the area and other factors that would be relevant to the formation of those coastlines. So again, just to repeat about lithology, lithology is the individual rock type, and that can have massive impacts on the rates of erosion. But although you might consider igneous and metamorphic to be the hardest rock, sedimentary to be the softest, then unconsolidated, it really depends on various factors, such as the surrounding rock types. What is it next to? Yeah, it might be a hard rock next to one thing, but soft next to another. Also, what types of erosion are likely to be in play there? And how might layers and bedding planes also make an impact? So finally, as a recap, lithology, yeah, is one of the key characteristics of geology, as is geological structure. But they are different things in terms of this specification. Lithology is talking about the individual rock, and geological structure is looking at how those rocks relate to each other in terms of location. So as I've said before, many students lose mark. They see a question on structure and give an answer based on lithology, or lithology and then answer about structure. You've got to understand the two. And while these are major contributing factors to the shape of coastlines, it's only one of the factors. And you also need to consider these other areas of wave energy, sea level rise, climate, physical processes, human activity. And you have to look at each individual coastline and see if you can assess or determine which factors were most important in that particular area, because these will vary. Sometimes the rock type is the most important factor. If you've got the very hardest of rocks, then the other factors will have less influence. So hopefully that has just summarized all the information on geological structure and lithology. Thank you very much. See you soon.